and take you to the practice quiz. So the exam has been graded, and you can check out the exam. I put comments on the problems that you got incorrect. And if you have questions on any of those, like you got something marked wrong, you can't understand my comment, not sure what you did wrong, you can ask me either during the break today or after class, any of those times. Great. And so practice quiz problem number 1. I'll give you a quick minute here. Okay, 20 seconds more. Okay, so at time 0, there was 100 grams. And then if it has a half-life of 8 minutes, that means in 8 minutes, there's going to be half of it, 50. And in 16 minutes, another 8 minutes, it's going to cut in half again, and it's going to be 25. So the answer is, how much time has passed? 16 minutes. Okay, give me a little feedback on this. Number 1. Okay. All right. The half-life erbium-165 is 10.4 hours. Right, you're going to start with the general modeling equation, and you're going to turn it into the specific modeling equation by getting all the constants you can if we start with 100 grams of erbium-165. So let me give you a minute here. Thirty seconds more. Alright, the general modeling equation for anything that has exponential growth or decay is the amount is the original amount, e to the kt. And the 100 is going to go in for the a sub 0. So we start out getting it more specific this way. But we need to know the k, and then we have the specific modeling equation. Now, the half-life is 10.4 hours really says this. If t is equal to 10.4, then a is 1/2 of what it started with. Now, let me plug this information in two different ways. One way I could be plugging it in is this way. I'm going to put in I'm going to rewrite this equation. Put the 10.4 in for the, it's supposed to be for the t. K times 10.4, and then the a could be 50 because it's half of what it was. The other way we could have done it is, let me just show you, if we didn't know the a0, we could have just had it like this. And then this, after 10.4 hours, it would be 1/2 of a0. Now, let me show you what happens in either case. When we solve for k, the first step, you divide by the a0, whether it's known or unknown. And then you're going to get 0.5 or 1/2 e to the 10.4 k. And this is going to give you 0.5 e to the 10.4 k. Either way, we come up with the same equation. Whether the original amount was given or not, that's why they don't have to tell you what the original amount is very often. You can still solve these problems without an original amount. And then we'll take we've got to solve this for k. I'm going to take the natural log of both sides. And then these cancel out. I'm going to get 10.4k. I'm going to put this to the other side. Just turn it around. So k is equal to ln of 0.5 over 10.4. And I could punch it out and get the decimal if I wanted to, but I don't have to. I can just rewrite my specific modeling equation now. It's what we had written before. A equals, we put 100 for the a0, we put this in for the k, and then t. That's my specific modeling equation. Alright, so give me a little feedback on coming up with the specific modeling equation from the half-life. Half-life information lets you find out what k is. And They also told us the A is 0. Okay. If an initial amount of 100 grams has decayed to 34 grams. So it's the same substance, so we get to use the specific modeling equation, figure out how much time has passed. So give you a minute for that. "30 seconds more. Okay, we're going to take this 34 grams and just plug it into here for the A, and then figure out what the T is. So 34 equals 100 e to the 5 over 10.4 times T. Now, this same thing could have been accomplished if they would have not told us 100 grams and 34 grams, but they had said 34% of the original material remains. How much time has passed? Because we'd have gotten the same thing here. First step, divide by 100, and we'd have gotten the 0.34. And then I'm going to take the ln of both sides. If it's already got a base e, then use base e in your logarithms. These kill each other off. And I'm going to get this. And I'm going to get ln of 0.34 on this side. And then I'm going to get t by itself. I'm going to multiply both sides by the reciprocal. And then I'm going to get my answer as t equals 10.4 times ln of 0.34 over ln of 0.5. This is what I call my exact answer. And then I'm going to punch it out on my calculator. And make sure you've done that as well. And I'll come up with 16.19 if I round that years. And the last thing I'm going to do is I'm going to ask, is this reasonable? Well, 100 grams would have decayed in 10.4 hours. See, we didn't make that chart here. In 10.4 hours, it would have decayed to 50 grams. So it's going to take more than that, more than 10.4 hours. Now, it wouldn't go all the way to double 10.4, which would be 20.8, because then the 50 grams would have gone down to 25 grams. So it would be somewhere between 10.4 and 20.8. And 16.19 is kind of halfway in between. Yes, it's quite reasonable. That's my answer. This one is my approximate answer. That one's my exact. Alright. Give me a little feedback. Did you need this review, or is it not needed? Not necessary, or is this helpful? Alright, I got a student from another class. Let me check in with him real quick. No. Alright. I'll get it during the break. Alright, so same situation, the erbium 165. Yep. How long will it take an initial amount of erbium 165 to decay to 20% of this initial amount? Let me give you a minute here. Thirty seconds more. Okay, so the specific modeling equation was this. So I'm going to start with that. equals, but instead of 100 as the original amount, they don't tell us this time. So I have to leave it as A0 to the ln of 0.5 over 10.4 t. So there's the specific modeling equation for this situation. And then, now, to decay to 20% of this initial amount, this has got to go in over here. Common student mistake, though, is to just put 0.2 . This would say that even if we started with 1,000,000 grams, how many down to 0.2 grams? No, it's 20% of the original. Of means times of the original amount. It's got to go like this. Okay, and then we solve this. First step, divide out the A0. Next, I'm going to take the ln of both sides. I'm going to get these to cancel. Turn this equation around. And I'm going to multiply both sides by this. And I'm going to get t is equal to, this is going to be my exact answer. And then I'm going to punch it into my calculator. And I get 24.15, and this was, how long will it take? About 25 years, or 24 years. Remember, this is my exact answer. I want you to label these like I am. Approximate answer. And then I want to ask, is this reasonable? And we can use the same kind of analysis that was used in this very first problem. It's just, you go 1 half-life, it should be half of what there, and so on. See, and it should lie in between a couple things. So, if we went 10.4 years, we'd have gotten to half. Another 10.4 years, which is 20.8 years, would have been 1/4, because half of a half is 1/4. Now 20% is almost the same as 25%, just a little bit more than, a little bit smaller than that. So a little bit more time than 20.8 years, and that's what we had, a little bit more than 20.8 years. So this is quite reasonable. Alright, and tell me if this made it more difficult for you when you had this. They didn't give you the original amount, but they had this 20% of initial. Did that make it tougher? Alright, so I am noticing today that Addison, you are the only person in group 3 that is here. So I'm going to give you another role. So, roles. You are going to be in group 3. Hold it, you're already in group 3. Let me put you in group 4 for today. I'm going to take you out of the group 3. And group 4, could you please welcome Addison to your group? Maybe send her a little welcome message and include her in today. And I think your group, Addison, has dwindled down. So I think I'm going to wind up leaving you in group 4. Alright, so you'll join that group, I think, permanently. And alright, so I think that's it for the practice quiz problems. So, questions that anybody has?
I have number 5.
And that was on the worksheet?
Yes.
Okay. And so let me go to the worksheet. That was the logarithms application. Alright, so let me take a bunch of this. Hold it. No, it wasn't there. It was way down here. Bird species. Alright. So, what I'm going to do is I will work on, I'll do part of this, but not the whole thing. So hopefully I get you past your sticking point. So who is asking for this?
Sasha?
Sasha? Okay. So I'll ask you for some feedback. Alright, so a bird species in danger of extinction has a population that is decreasing exponentially. 5 years ago, the population was 4,000, and today only 1,000 birds are alive. Alright, now if I was going to make a little table for this, I might do it like this. 5 years ago, I might call time 0. Sasha, go ahead and turn off your mic right now, and then I'll have you turn it back on when I ask you. And then today is, so we started the clock 5 years ago. So today will be 5 years later. Like this. And then we're going to be asking, when is this amount going to be this? Alright. So the modeling equation for this is going to be, let me go to a different color here. Since at time t0 is 1400, I can start right away by putting 1400 e to the kt. Now we need one piece of data to allow us to get the k. Then we have the specific modeling equation. Usually that one piece of data is they tell us the half-life. But they don't have to. They can give it to us in a different way. And this time they gave it to us this way. When this is 5, this is 1000. And then that's how you're going to find k. And then once you have k and a0, then you can write your specific modeling equation. And the specific modeling equation will be this one, but the a0 will be 1400 and the k will be whatever you got when you did this. And then from the specific modeling equation, you can plug in a is 10 and then solve it for t. Sasha, is that enough to get you going on that?
Yeah, I think I think I can go from there.
Okay. All right. Good question, though. This was kind of a little bit of a tricky setup. All right. Any other questions? All right. Let's go to today's topic. Compound interest. And so part 1 is loans. And you borrow $10,000 for a car at 5% yearly interest to be paid back in equal monthly payments for 4 years. Now, pull out your calculators and you'll see that I'm doing this right. The interest each year is $10,000 times 5%. And if you multiply these two with your calculator, you do get $500. The interest total then. So you're going to be paying $500 a year in interest. And yeah, you're paying it back over 4 years. So $500 times 4 years. You multiply those out with a calculator, you do get $2,000. So all my individual computations are correct. So you can see that you're paying $10,000 for the car and you're paying $2,000 in interest. So your total cost is going to be $12,000. Now you're paying it back once a month for 4 years, so 4 times 12 is 48, so there's 48 payments. $12,000 divided by 48 gives you $250 per payment. Punch that on a calculator, that's correct. All my computations are correct, and all of it would seem reasonable to me if I was looking at this for the first time. But this is not the correct way to compute interest. In fact, if you went and bought a car and they computed the interest this way, you could sue them because they're charging you way more than they're supposed to. Even though 5%, this is not the way the interest is computed. There's something logically wrong with this. And that's what you and your group are going to discuss now. Figure out what's wrong in this scenario. Although the computations are correct, this doesn't make sense as far as how interest works and paying back loans work. All right, so give your group, go ahead and, as you think about it, type in your ideas into your group chat, but don't hit enter yet. Let's let everybody kind of think it out individually for a minute, and then I'll give you some group time to process as well. Okay, go ahead and hit enter and talk it out in your group. Okay, let me have you stop now. And before I go on, before I forget, let me tell you that we are at the quarter point in the class now. So what I'm going to do is I'm going to switch roles for each group. So whoever was the backup is now the leader, and the leader is now the backup. And so in group 1, leader is Brianna, and the backup is Sasha. So Brianna, your task when you first enter every day is to remind your group who the spokesman for the day is. And just rotate that around however you decide to do that. And then group 2, leader is now Annika, and the backup is Aiden. And group 3 has gone away, lost members. Group 4, we seem to have lost a person. So in this group, so Maya, you are the group leader, and Lily, you are going to be the backup. Right. Now, with the loans situation, group 1, anything you've come up with, any possibilities, what could be wrong with this?
Hi, this is Nika.
Hi, Nika.
Hi. So I was thinking that the interest would, step 1 is wrong because the yearly interest shouldn't be paid on the original amount. As the amount is paid down, the interest payments would also go down. So only the first interest payment would be 500.
You are more correct than you're realizing possibly. What happens, you hit it right on the nose. By the time that you've, like 2 years has passed, you don't owe $10,000 anymore. If about halfway through the loan, you've paid off about half of the car. So about the halfway point, you only owe like $5,000 now. And so you shouldn't be paying interest on the full $10,000. And in that last year of the loan, you've paid off most of this $10,000. But this is still charging you as if you still owe $10,000. So you're labeling it right here. This part is really wrong. How these have to work, and how a real loan does work, is every time you make a payment, it's how much do you owe, and then you multiply by 0.05, and then you divide it by 12, because that's your monthly interest rate, because you wouldn't want to be charged a whole year's worth of interest each month. So divide it by 12, and then that amount is how much you've got to pay, and then that'll reduce the $10,000 that you owe, and then you'll owe less, and then the next month you have to go from the amount that you owe at that time, and then you're multiplied by 0.05 divided by 12, and so on. So this is charging you approximately double the amount of interest that it really should be. And so your effective interest rate here would be more like 10% if they were doing it this way. All right. So if we want to describe this in words, is as you're paying off, the amount you're borrowed, decreases. All right, now typically it takes a while for most, usually it's not the first group that I call on that has this one correct, so that's very unusual. All right, all right, so we're going to be looking at compound interest, and this was just kind of a thinking question to just get us going in this direction. All right, now compound interest, where we're really going to look on it is not on loans but on savings. Okay, and we're going to learn how to compute compound interest a very fast way. And this is where we're going to pick up, but right now we are at a break time, so let's start again. At 1:31 p.m. And before I take my break, is there anybody who would like to talk to me individually? Is there something on the exam that you want more clarification on? Be happy to talk about that, or anything else. Okay. All right, so let's go over compound interest on savings. All right, so first question is if $200 earns 8% interest, what's the total amount of money after 1 year? So let me give you a quick 30 seconds, figure out the answer. All right, so let me show you how most of my students answer this question. They take 200 and they multiply it by 0.08 because 8% has a decimal. 200 times 0.08, I'm punching out in my calculator, is $16. And then they add the 200 and they get $216. And it's usually a two-step process. One to earn the interest and then the other to add it in. So if you did it basically that way in 2 steps, go to the main chat channel and type in yes. And let's just see how many of you did it basically that way. In the past, most of my students seems to have done it that way. Okay, and I have a few. Alright, now that is what we call the slow way. Okay, and it takes 2 steps, and we won't be able, if we keep doing it the slow way, we won't be able to get shortcuts that we're going to need if we're going to find out how much money we're going to have in like 30 years or something like this. It'd take way too long if we're doing it the slow way. So we have to do it the fast way. And the fast way is shown right there. And let me just do it with the fast way and just show it. Alright. So, fast way instead of the 2 steps, $200 times 0.08, so on, it's this. 1 plus 0.08. Now, when you just use the distributive property, because it would actually add these two together, 1.08 times 200, and you get the right answer, 216. And it'll happen in 1 step. But why does it give you 216 the correct answer? Because notice when you distribute this times this, it returns the original principal. And when you send it to the next one, it adds the interest. So you get the 200 plus the 16, giving you the 216. This took 2 steps, get the interest, and then go back and add the principal again. Alright, so that's the fast way. So practice the fast way with, let's go with these 2 problems. Just get used to doing it the fast way. 10 more seconds. So this first one, it's 340 times, instead of 0.05, it's all in one step, 1.05. And then that, punched out in the calculator, $357. And this one, $500, 4% interest, and you can put the plus in there or leave it out. Sometimes I put it in there, sometimes I leave it out, doesn't matter. And then, so this is going to return the principal, that's going to add the interest is going to be $20, and so you get the whole thing, $520. Okay. And, alright, I think you got it. Let's skip C. Interest earned over multiple years. Let me have you do number 3, A and B. I'll give you a minute. Alright, let me have you stop. So this first one, $260 after 1 year. So we're already familiar with this, $283.40. Alright, what's the amount after 2 years? Now, there's 2 ways you can do this. And I'm going to say the slow way is this. You take the 283.40 and you multiply that by 1.09. Now that seems kind of fast. Why is this going to be called the slow way? Well, let me tell you in a moment. 308.91 is what you're going to get. Now, why would this be called the slow way? Because if you wanted to go to this one after 30 years, you'd have to go through all the years in between. So this is the amount after 2 years. To get the amount after the next year, you got to start with this and multiply by another 1.09. When you multiply this by the 1, it returns the principal, and there it adds the 9% interest, and then so on. But you'd have to go, you're going to be doing this 30 times. So, the fast way is, now let's make kind of a little table about this. Time and amount. At year 0, you have $260. At year 1, you have 260 times 1.09. Now, year 2, instead of taking this $283.40, all you do is you leave it as this. So we'd be tempted to put 243 283. Oops, I put it in the wrong place. We'd be tempted to put $283.40. But instead, we're going to put that it's 260 times 1.09. Now, we take this and we multiply the 283.40 by what? By 1.09. And what we see is this. 1.09 happens twice, it's squared. And what we see is, after 3 years, we would take the answer from the previous one, multiply it by another 1.09, so we'd get 260, 1.09 to the third. The next year, we'd take the previous year, but now the pattern is nice and clear and obvious. So we could jump all the way to 30 and say, oh, the 260 always happens just once. The 1.09, the exponent, is always the same as the year number. So it's to the 30th power. And so we don't have to go through all the others to get this. And so then we punch this out on our calculator, and I'm going to get $3,449.60. Okay. And here is that explanation kind of in the format. Basically, I didn't need this because I wrote it out this way. Yeah. So, give me a little feedback on this. Am I going too fast, or is this sinking in well? Are you kind of comfortable with this? Tell me where you're at. If everybody can give me a little bit of feedback. Okay, yes. It depends on who you had for your college algebra instructor, whether you did it kind of this way or not. All right, now. Okay, so let's jump to the answers to, let's go to number 4A. So following the pattern that we've just learned, see if you can give me the answer to 4A. And when you get your answer, type it into your group chat as well. But wait just a minute, I'll give you the cue when I want you to hit enter for your group chat. In the group chat, you could type in how you're getting your answer as well as what your answer is. If you raise to a power, you can use Shift 6, the up arrow, kind of demonstrating that's how what you're doing. Okay, go ahead and hit enter. Okay, group 4. What'd you get for this? So group 4, Maya, are you there?
I don't think she's here today, but
Okay.
what I got was 500 and then 1.11 to the 30th power. And I didn't get to type that out in my calculator because it died, but one of my group mates said that it was, sorry, give me a second, was approximately 11,446.
And if we round it to the nearest cent, I think it comes out to like 15 cents. Something like that. All right. So by getting this, we're using this idea right over here, is that the 1.11 is the multiplier that happens every single year. And so it's $500. The amount after 1 year is you'd have this to the first. And by the time you get to 30 years, it's 1.11 to the 30th power. And this is a really, really powerful tool that you can use. And a lot of investment decisions that people make are made in a very, very short amount of time. And sometimes the screws are on you, and you have to make a really big decision that impacts your future, and you only have 2 or 3 minutes to decide. You might be at a bank doing something, and you're asked a question about if you're refinancing your house or something like this, and if you want to pay more money for a cheaper loan, and all kinds of things, and having tools that you can use really quick has been really helpful for me at times to make big decisions. All right, and this is one of those tools that works really quick. All right, I'm going to skip over B. It's the same kind of thing, and I'm going to jump right to 5A. So 5A, find the total amount of money after 1 year if $100 is invested at 6% yearly interest, compounded semi-annually. It means that it's compounded twice per year. So after 6 months, you're going to get some interest, and then at the end of the year, you're going to get your interest, and figure out how much you're going to have. And now I haven't told you what it means to compound semi-annually, but I want you to make a guess at this. You're going to get a whole lot more out of this if you make some kind of guess, and then we refine it. Make a guess, type it into your group chat, but don't hit enter yet. Let me just look at the last feedback real quick. Alright, not going too fast. Okay, go ahead and hit enter. Your group chat, talk it out. If you really can't think of anything, at least put in that I'm stuck. But do something into your group chat. And group 2, what do you have for this?
We got $112.36.
Can you tell me how you got that?
Yeah, so we did 100 times 1.06 to the second power because we're multiplying 1 year by 2 semi-annual
Gotcha.
compounded things. Yeah.
Great. And this is Annika, right?
Yes.
Yes. Okay. All right. Annika, this is exactly how I would have approached this my first time looking at this. But it turns out that this is wrong. It seems so intuitive, like, you get the 6% twice, but actually you don't. Banks use this all the time. They compound more than once a year, but they don't give you the full amount each time they do the compounding. So let's cross these out. And let's go to this. Here's the contract. And let me space this out a little bit. I will let the bank hold my $100 for a full year, and they will give me 6% interest. After 6 months, have I fulfilled the entire contract? The answer is no. What fraction of the contract have I fulfilled? Exactly half of my contract. The time that they're holding my $100 is a giant part. If you give it to them for a second and then pull it back, it ain't worth much. If you give them for half a year, they get to invest it or do whatever they want. But you haven't given, so you've only given them for half the amount of time, they only owe you half the interest. What fraction of the contract have I filled? A half. Since I've only fulfilled half my contract, what fraction of the interest is owed me? 1/2. So, we're going to fill in this chart, but we'll give only half the interest after half a year, then the other half at the end of the year. So, the time is 0.5. The amount is 100. 1 plus, now 0.06 is the interest rate, but you're only due half of it. Now, very significant to note that some students make this mistake. It's not that. Because this has still got to return the full principal. It's just the amount of interest gets cut in half. Don't do this, just cut your interest portion in half. Now that turns out to be 0.03, so this turns out to be $103. Now 103 is what you start the second part with. Now you're due the other half. And when you multiply this together, 1.03 times 103, you wind up getting 106.09. Now, let me tell you, up here, this situation would have what you would call an effective interest rate. 12.36%. Because $100 turns out to be 112.36. And if banks were compounding interest and doing it like this, they'd quickly go out of business. They'd be giving away too much money to everybody who invested in them. This, when they compound it the way they actually do it, for compounding it semi-annually, is effective interest rate of 6.09%. So 6% interest, but effectively 6.09, is they're only giving away 9 more cents. Banks can handle this. So that's how they do the compound interest. Now, question that would smack me in the face would be, where'd that extra 9 cents come from? And I'm going to throw that up to anybody. Can anybody tell me where this extra 9 cents came from? Turn on your mic if you think you got any idea about that.
Hi, I think you're paying interest on the interest, aren't you?
Which is how much? 9 cents.
9 cents.
Pardon?
9 cents?
Yep.
Or 0.9 cents?
And it's actually the half year's interest on this $3 extra right here. If this had been $100 again, you'd have gotten, as the input, you'd have gotten another $3 added to this. But it was $103 at the halfway point. And the interest on the $3 gives you that. So I think that's what you were saying. The interest on the $3 is 9 cents. Half a year's interest on $3. So you wind up getting a compounding within the same year. Interest on your interest. And so that's one of the reasons it's called compound interest. And then you get this little extra over here. All right. Now when you take money out of the system, that's called simple interest. If every time you get interest, they send it to your home instead of reinvest it, that's simple interest. All right. Now, we're going to do the same thing again. But this time, we are going to show the process instead of the totals. So, I'm going to write down almost the same thing. But I'm not going to write down that that's equal to 103. And then at the beginning of the next year, it's really $103. But instead of writing it as 103, I just write it like it was. And then what do you do with that 103? You multiply it by another 1 plus 0.06 over 3 to give it another half year of interest. But then what does all this become? This is twice, so it's to the second power. All right. And so we're starting to see a process with compounding more than once a year. We're going to get a more complicated expression here. All right, so number 7a. Now we'll predict the expression that represents the total amount after $100 is invested at 6% interest, compounded semi-annually for 10 years. Now, I want the expression, you don't have to punch it into your calculator, just come up with the expression. So go ahead and type that into your group chat, but don't hit enter yet. Take a guess. Go ahead and hit enter. All right, group 1. What's the expression that you have here?
I think we're still thinking about it for another minute.
Okay.
Yeah.
All right. Let me give you a little more processing time. And if you want to pass, you can just pass as well. That's fine too.
Maybe we'll let the next group do this one.
Okay. So let me go to group 2. What do you have?
We got 100 times 1.01 plus 0.06 divided by 2 to the 10th.
Okay. This is saying that the $100 keeps getting bigger and bigger powers on this expression the longer you put it in there. And you are really close with this. But there's one part of this that needs adjusting. And that is this. It's not to the 10th. It's to the 10 times 2, which is going to be then 20. Now, why in the world is it going to be that? Why doesn't just the year show up? Well, because look at the end of 1 year, what was the exponent? 2, because there were 2 compoundings each year. Half the interest rate, but double the number of times you got interest. So if 2 is going to happen in 1 year, 20 is going to happen in 10 years. It's going to be the number of years times the number of compoundings each year. So that got us going on that. We just refined it a little bit, and we've got an expression for that. All right, let's do the next one. Make an expression for $100, vested at 6% interest, compounded semi-annually for 15 years. I'm going to give you 30 quick seconds. All right, this one turns out to be $100. 1 plus 0.06 divided by 2 to the 15 times 2 each year. And so that's going to turn out to be 30. Now, I always cross it out and replace it with its result. Because when you punch this out in a calculator, if you do parentheses raised to the 15 times 2, the calculator will do the exponent first and will only raise it to the 15th power. And then it'll figure out that answer, and then it'll multiply times 2. So I always do that part first. Okay? Now it gets more tricky here. And this sees if you're getting the concept behind it. $100 is invested at 6% interest, compounded quarterly for 1 year. Figure out the total you're going to get after 1 year. Write the expression for it. When you get that expression, put it into your group chat, but don't hit enter quite yet. Go ahead and hit enter. Group 4, what do you have here?
We have 100 times 1 plus 0.06 divided by 4 times 4 to the times to the power of 4 times 1. Sorry.
All right, so what happens is, since it's compounded quarterly, at the quarter point, when 3 months has passed by, you're going to get you're going to get 1/4 of the interest that's due to you. And then at the halfway point, and then the 3/4 point, and then at the end of the full year. So it's 1/4 of the interest, but 4 times it happens. And I like you put 4 times 1, and then we replace that with its total, which is 4. Okay, let's go to the next one. $100 invested 6% interest, compounded quarterly for 20 years. I'm going to give you a brief 30 seconds, and then I'm going to put the answer up. Okay, this is $100. 20 years, but 4 times a year, which is 80. So it's raised to the 80th power over here. Any questions? Okay. And then, if we were doing this in college algebra, I'd have you practice punching these into your calculator. We're going to skip that. We're going to go the variables in the compound interest formula. Okay, so the total amount we're going to call A. The initial principal is called P. The interest rate per year, and you write it as a decimal, is R. The time T in years. And the new one maybe for you is N, is the number of compoundings in 1 year. So for instance, if it's compounded quarterly, N is 4. If it's monthly, N is 12. Weekly is 52. Daily, 365. Now these last two aren't exactly correct, but that's what we'll use for these computations. Because there's things like leap year and so on. And there's not exactly 52 weeks in a year. All right, so number 10, when $100 invested at 6% interest, compounded quarterly for 20 years, we get this expression. We just did that. The 80 comes from multiplying the n and the t, 40 years, 20 years, and n is 4 when compounding quarterly. Replace each number in the equation there with the variable from up above, from this was 9. But when you're done, you'll have constructed the compound interest formula. All right, so construct the compound interest formula, write this formula again, exactly what we're seeing here, you're going to write down here, but replace the 100 with one of these letters and then keep going, and then when you're done you'll have the compound interest formula. Let me give you a minute. When you get your answer, type it into your group chat. Okay, go ahead and hit enter. And group 1, what do you have for this?
We don't have a group answer yet, but I was thinking it might be A equals P parentheses 1 plus R over N raised to the NT.
That's exactly it. Okay, and there's the compound interest formula. And this is one of the formulas you're going to have to wind up memorizing in this class. So what I want you to do is study this formula for a moment, and then look away and write it down from memory. So let me give you 30 seconds to do that. Okay, and since this is a pre-calculus class, we have more here, and we're going to do continuously compounded interest, but we've run out of time. And then at the end of this, there's homework problems. And if you look in the modules, you'll see the homework problems for this. And you can do the first probably half or more of these with what the information you have right now. We don't have the continuously compounded. We haven't done that yet. We're going to finish that up Tuesday. But get started on this. I'll be, you only have to, instead of having 3/4 of it for the spot check, I'll say you only have to have like half of this for the spot check. So this is the homework. But it's in the modules. There's a file there that has these things, and it has an upload button for it. And we will stop here. Any questions? All right, I will see you